Hello viewers, welcome back to class. I'm super excited to have you guys back to class again. Don't forget our policy here that you should not skip any part of this video. Ensure you watch this video seconds per seconds, minutes per minutes, and hours per hours. Very important. This will help you not to miss vital information that will help you gain mastery over this aspect of this topic. Now, guys, don't also forget that anytime you are set to learn and to get new concepts from us, please avoid every unnecessary distraction. Make sure you pay close attention so that you will be able to maximize every little information that we have in stock for you. Finally, if there be any part in this video that you do not understand after you have watched it for the very first time, please, guys, you have the singular opportunity to replay the video over and over again until you understand it. That's why this lesson is coming in video format. Guys, don't forget to subscribe. Don't forget to turn on the post notification bell for more exciting videos. Share this video, like this video, and make your necessary comment. Guys, shall we get to work? Now, on the board, we have second order differential equation. This is a continuation class, as we all know. All right. So, if you are visiting this page for the very first time, and this happens to be the first class you are having with us on second order differential equation, kindly go to our playlist session where you will find a session for first order and second order differential equation so that you can look at lessons that we have looked at before this current lesson. Okay, now if this is understood, now we are providing solutions to second order differential equation. And now on this particular case, we are looking at case 2 when f of x is not equal to 0. Now, when we look at case 1, we said that second order differential equation can be solved under two categories. The first category is when f of x is equal to 0, which is the function at the right hand side of the equation. But in this case too, we have the function of x not to be 0. That means it exists. And if it exists, it can be any of the mathematical functions that we have explained in our previous lesson. I'm going to take time to also explain this explicitly for your own understanding. Now listen carefully. So we said that f of x is equal to any function of x. Any function of x. And of course, we know that the general equation is given as this. So it is this right hand side that we said is no longer equal to 0, like we have treated in the first lesson or in the previous lessons. Are you there? Now, the general solution to this guy is given as y is equal to complementary function plus particular integral. And now, which we have a summary as y is equal to cf, which is complementary function, plus the particular integral. Of course, you are not strange to this complementary function. Okay? How do you obtain complementary function? The complementary function is that function you obtain when you solve the second order differential equation by quadratic formula or quadratic method. Now listen carefully. Anytime you equate the left hand side of second order differential equation to 0, the result you obtain is what we term as complementary function. And remember, in case 1, all the problems we solved, they are all complementary function. The particular integral in that case was equivalent to 0 because f of x was 0. So the particular integral was 0. So all the results that we had for case 1 when f of x was equal to 0 were all complementary function. But now that f of x is not equal to 0, the particular integral is not equal to 0. It exists. Are you there? So now let me quickly remind you of what this particular complementary function is all about. Listen carefully as you begin to solve problems under this case 2. We are still going to be given equations that are related to the ones we solved when f of x was equal to 0. So that means you are still going to have any of the 5 categories that we had when we were solving a case where f of x was equated to 0. And what was those categories? The first category that we had there was that we have real and different roots. And we said for real and different roots that the complementary function was equal to a m1 x plus b e m1 m2 x. This is what the complementary function for a quadratic equation that has real and different roots. So when you are solving second order differential equation under a case where f of x is not equal to 0 or equal to any function of x, you must understand that you must first of all calculate for the complementary function. How do you calculate for the complementary function? You have to first of all assume that f of x is equal to 0 so that you can calculate for the complementary function. And when you calculate for the complementary function, when the outcome you have, the value of n that you have is real and different root, this will serve as your complementary function. You are done with that. Then also, if the outcome you now have is real and equal root, then you have exponent mx into a plus bx. So like I explained in our previous lesson, I made it clear that it is the outcome of n that determines the particular solution you are going to use. So if the value of n that I have is equal and real, therefore that means I'm going for this. So you don't really need to be told that you are going to be using this or this. It is the outcome of your answer, the results or the values you have, the roots of the equation that determines the option that you are going to pick. Now we also mentioned that the case where we have complex roots, and for complex roots we say the complementary function, which is what is equivalent to exponential alpha x open bracket a cos beta x plus b sine beta x. All right, this is what we said when we have complex roots. You get alpha and get beta from the complex results that you have. Then also we have complex perfect roots, square root. Complex perfect square root, where we have plus and minus. And for the plus, we said that this is equivalent to a cos nx plus b sine nx. While the second case, the last case, which is the fifth case, is a cos hyperbolic function nx plus b sine nx. So you see that these are the 5 general solutions to complementary function. So any second order differential you will be given must fall into any of these categories. It must be one of these options. And what determines the option you go for, like I explained, is the outcome of the roots. So if the roots are equal and real, go for this. If the roots are real but different, go for this. If the roots are complex, you go for this. And if it is a perfect square, where you have addition between them, you make use of this. And if it is a perfect square, when you have subtraction between them, you make use of this. These are the 5 categories. So as we begin to solve problems under case 2, when f of s is not equal to 0, this is the first thing you must calculate for. Are you there? By equating the left-hand side of the equation to be 0, or making the right-hand side 0, taking f of x as 0, so that you will be able to deduce the auxiliary equation, solve the auxiliary equation, obtain the value of m. Whatever value of m you have determines any of these options you will go for. That has served for it. Now, what about the particular integral? How do I obtain the particular integral? Of course, you don't have issues with this any longer. This is what is strange to us now if you have actually studied the first aspect of this second order differential equation. Are you there? Now, listen carefully. How do I get solutions to this particular integral? Also, we understand that to get the complementary function, it highly depends on the roots of the equation, right? Similarly, to be able to get a particular integral, the particular integral also depends on the function of x. Are you there? Now, what are the functions of x? Listen carefully. Mathematically, we have numbers of functions of x. First, we have constants, okay? So if f of x can be what? Constant, which is k. When I mean k, it can be 4, it can be 28, it can be anything without x. Are you there? This is a function of x, constant. You must look out for what is the function of x. Also, another function of x that we know is linear equation, where this can be what? Kx. An example of this is 2x or 8x minus 1. These are all linear equations, any of these, or plus 1, whichever case you have it. These are all linear equations, in as much as the degree of x here is 1. This is linear. Then also, a function of x can be quadratic, which is kx squared. And this can equally be what? 2x squared or 3x squared plus 4x plus 1. Everything here now is quadratic. It can be one term, it can be two terms, it can be three terms. But your attention is what is the highest degree of x. So if the highest degree of x is 2, that means it's quadratic function. So to also solve quadratic function, there is what? A formula to calculate for the particular integral. So when we begin to take them section by section, then I will begin to give you the formula. Now, another function we have is what? The trigonometrical function, whether sine or cos x, whether you have sine x or cos x. These are also what? Functions of x, trigonometrical functions. Then we have f of x can be what? Exponential function. Okay? Exponential function. So when you have an exponential function, the way you treat problems on exponential functions is also different from the way you treat either trig, quadratic, linear, or constant. Are you there? Now, if this is understood, so many other functions like that, hyperbolic function, inverse function, and so many other functions. So we will begin to take them one after the other. But understand that for you to be able to obtain the solution to your particular integral, you must first identify the function of x. So if it is a constant, I will give you the formula to calculate the particular integral for a constant. Alright, so we are still going to be taking this subtopic by subtopic. When it is constant, we will solve two problems. When it is linear, we will solve two problems. When it is quadratic, we will solve two problems. When it is a trig, we'll solve two problems on sine, solve two problems on cos. When it is exponential, we'll solve two problems. When it is inverse, solve two problems. When it is hyperbolic, solve two problems. Just like that. When it is logarithmic, any function you can think about. These are all functions of x. So understand that the particular integral actually depends on the function of x that you are given at the right hand side of the second order differential equation that you are given. So you need to pay attention to that. So in this lesson now, what you should learn is that for you to be able to provide a solution to second order differential equation when f of x is not equal to 0 or when f of x is equal to any function of x, one is to first calculate for the complementary function. And to calculate for the complementary function, all you simply do is to take the right hand side of the equation as 0. So that from there you can deduce the auxiliary equation, just as we have been doing before now. You will deduce the auxiliary equation. Then from the auxiliary equation, you will now obtain the value of m. And when you obtain the value of m, the results you have, the roots of m that you have, will now determine any of these 5 complementary functions you will go for. Are you there? These are determined by the results you have when you calculate the auxiliary equation or when you solve the auxiliary equation. That is for the complementary function. So understand that the complementary function highly depends on the roots of the equation. So if the roots are real and different, go for the first option. If the roots are real and equal or the same, go for the second option. If the roots are complex roots, then you go for the third option. And if the roots are perfect square plus or minus, then you go for the last two options, depending on what you have. This is how complementary functions are solved. You must take the right hand side of the given equation to be 0 for you to be able to obtain the complementary function. Now, for the particular integral, you must be able to identify the function of x that you are given at the right hand side of the equation. Like we said now, you can be given a constant, you can be given a linear equation, you can be given a quadratic equation, you can be given a polynomial equation, you can equally be given trigonometrical equation, you can be given a hyperbolic, you can be given what? A logarithmic, you can be given inverse, and so many other functions of x that you can think about in mathematics. So the shortest way to obtain a particular integral is that once you are able to identify, now listen carefully, let me quickly explain what you do to the particular integral. Once you are able to identify the function you are given, what you do to the function is to differentiate the function two different times. Are you with me? Listen carefully, like I've explained before, when you know rules, you follow it, right? When you understand principles, you become a principal. Likewise, when you understand boundary conditions, you will not overstep your boundary. This has been our what slogan here. So you will seek to understand principles and as well seek to understand the boundary condition so that you will not overstep your boundaries. Now listen carefully. So if I know that the given f function of f that I'm given at the right hand side of the equation, okay, is a linear function, constant, polynomial function, exponential function, what must I do to this? It is not all about knowing that this is a function. When I identify that this function is this, what will I do to it? This is it now. So this is where you need to pay attention. So first is to identify the type of function. Now that you have identified the type of function, because you actually have 3 steps to take to be able to what? Obtain the particular integral. So first, identify the function. Secondly, differentiate the function 2 different times. Why do I need to differentiate the function? Because for me to be able to find a particular integral, I must substitute the function into the given equation. So if this is the given equation, now the particular integral I identify here, which is the function, will be taken as y. Already know. So when I differentiate y, I will have this, which is the first derivative. And when I differentiate the first derivative, I will have the second derivative. So one of the reasons why after identifying the function you need to differentiate is because you must have to substitute that function back to the given equation. And for you to be able to do that, that means I need to know what the derivative of that function is. Understand, like I said now, that what you are going to get from this function is y. Understand that f of s likewise is given as y, right? Yes, f of s is given as y if you understand differentiation and integration very well. Now listen carefully. So what we are saying here is that the f of x that you are given here, after identify what it is, the type of function it is, then you need to differentiate. When you differentiate, now that will be your y. After identifying the function, that function will be taken as y. When you differentiate y, you will get this. And when you differentiate this first derivative, you will get the second derivative. After you have successfully obtained these 3 results, y, the y over the s, and this square y over the s square, you will now substitute it into the given equation. And that will enable you to find the constants that are involved. When I mean the constant, I'm talking about the arbitrary constant. You understand that from the complementary function, I already have a and b as the arbitrary constants. Are you there? So when I come to the complementary function, the arbitrary constant starts from c because I already have a and b. So it starts from c. Depending on what you have, there are some cases where you only have c. There are others who have c, d. There are others who have c, d, e. There are others who have c, d, e, f. Just like that, depending on the function. So understand that you already have a and b from complementary function. So for particular integral, your constant starts from c, which is the arbitrary constant. So for particular integral, you must ensure you are able to find the actual value of those arbitrary constants you will introduce that starts from c to any other depending on the function. Are you there? So once you differentiate that function, you will have to come here and substitute here. Once you substitute here, from here now you will deduce or obtain the value for those arbitrary constants, which can be c, cd, or cde, depending on the function. And after you have successfully gotten that, then you will come back to the complementary function, substitute their result, then come here, add up the 2 results, you are done. This is it. You may not be able to get it, grab everything in details, but let's start solving problems one after the others. I believe that your eyes are going to open very soon. Then you will get the real fact of what we are discussing here. Don't forget, don't rush. Watch this video over and over again so that you get the details. So if you have not understand what I have explained so far, please rewatch this video over and over again before you slide down to the description below, where you will find a link to the next video where we now start solving problems using some of these rules and principles that I have given to you. So guys, don't forget, to become a principal, you must know principles, and to maintain your boundary conditions, you must know boundary conditions. Listen carefully. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting video. Guys, like this video, share this video, and make your necessary comment. Don't forget, love you. See you guys in the next class.